Okay, I had this LG 32LN 5400, it's a 32 inch full HD LED backlit TV. Common issue, like many other LED TVs, is sound, no picture, and the backlight wasn't working, of course. So, and this video is just to say, you know, you should always diagnose before you tear things apart. Now, I thought we had a failed LED in the screen, and indeed, when I tore this thing apart, one LED in the screen was failed, and I replaced that. You know, sealed it all back up, hoping to get backlight, and, you know, everything else tested perfect, and all the connections tested fine. Sealed it all up, and, you know, no backlight still, so I was like, oh, what next? So I was checking out the power supply, and the LED Plus should have, when this thing is working, and they actually label the output on this, the LED output should have 70.3 volts on it. I was only getting 48 volts on the white connector there, which told me straight away the LED booster is not working. You know, I have my black probe of my meter on chassis ground here, and my red probe on there, and you should still see the same voltage, and I was only getting 48 volts, and this panel I think had about 21 LEDs in the screen. Each LED uses 3 volts, so you do 21 times 3, that's 63 volts or so roughly to get these started, but this does use a PWM based dimmer, so they lower the current and increase the voltage to about 70 volts on startup for the PWM circuit. Now again, I was getting 48 volts when this thing was in standby and when this thing was running, and 48 volts for LEDs in series that need, you know, 70 volts or so. It's not going to work, obviously. So I was checking out the power supply, and I was finding that the LED MOSFETs, which I'm going to show in a second, weren't being turned on enough. They weren't receiving a VCC voltage, which is the voltage that tells the MOSFETs to drive and create the boosted voltage for the LED strings. It's a bit like a DC converter. They use this little buffer transformer to create the 70 volts from the 24 volt rail on the power supply. So then I was tracking it down, and I found that the LED driver chip was actually faulty. It was getting all of its you know, signals to drive the MOSFET, but it was only outputting about 0.6 volts for the VCC for the MOSFETs, and you know, that's not enough to turn them on basically. So I changed the LED driver in standby right now, and as you see, after changing it, backlight straight away. Now the LED in the screen was shorted. Originally I think I said it was an open circuit on bad caps, but it was actually shorted. And as you see, the screen is all fired up and all working. And I've only actually just got done fixing this, so pretty sure, oh, it might fall off. I did have the old chip on my soldering iron, but I'll just show you the chip that I replaced. But I'm just going to turn this off because the backlight is on full brightness and I don't want to burn out any LEDs in the screen. But I thought there was no PFC on this. Basically, you know, the time I made this thread on backups I wasn't well. And I had a bad day, so I was messing things up, but I said no PFC because there was only 360 volts across these caps. Now this supply doesn't have a PFC circuit, so you should only see about 360 volts across those caps anyway, even though strangely they are 450 volt rated. So, you know, I did suspect the driver at start, but you know, I hadn't tested it at this point, and the driver used on this board, which the board, by the way, is an EAX 64905001. The driver IC is a MAP3202, and the other numbers on it are DR8839GP, but the only numbers that matter are the MAP. I think he was supposed to put MAP, but he only put MP. And Budum links the schematic for this, and I tested it, and no VCC drive voltage, so of course without that the MOSFETs can't turn on and the LEDs can't be driven. So I'm just going to show you the chip that I replaced, and it's on the bottom side of the board, by the way, so I'm going to have to take this out. But I just want to show you it just to so you get an idea of where it is on this little board here. It's only I think 70 watts or so, or oh, this is actually 80 watts, this TV is. It's only 80 watts, but they still develop faults, these little power boards do. You'd think with little power supplies they'd be able to design them a little better, to the point where they don't really get that hot, because it's only 80 watts of power going through it, but some of them they're not that good. So I'll just show you the driver chip now. Okay, so I've just got this flipped over here. I've just got some tissue on there just to stop the heatsink shorting out on the chassis, which, because I've only just had this plugged in, the caps might still have some voltage in them. But I've got this flipped over. Here's the LED connector, so you can get an idea on the orientation of this. Now the LED driver chip is this one here that I've changed. Now you'll notice there was a pad lifted by accident, and it serves me right. The solder traces on this board are very flimsy, and I was using some solder wick with no flipping flux, and I hadn't even fluxed up these pins either, so a trace did lift off, but I was able to fix that easy. I don't normally tend to lift traces, and I haven't done it in ages, and I'm not normally one to commonly do it, but in this case it was an accident. But here's the chip all soldered in, and I'll just show you the part number on eBay. This was only a few pounds on eBay, so pretty good TV fix for a couple of quid. And these are the two driver MOSFETs for it. Just load up my eBay here. So where is it? It was quite a while back. Here we go. Blah blah blah. Here's the chip. So it's a MAP3202 white LED driver. It's a SOP 14 SMD package. £2.80 plus 65p postage. And you just need a bit of skill with SMD soldering, and you can fix your TV basically. So I'm going to seal this up, and I'm just going to show you a couple of things I do on these LED backlit TVs just to help them be a bit more reliable. And this motherboard here also has a lot of issues with the BGA solder failing, so I'll just put a little heatsink on the chip, because they don't actually heatsink this main processor. So any of the LN series, you should heatsink this main processor IC, because they do have a lot of issues with BGA solder on this series, and the LED backlights and the power supplies as well. So, but there's the chip all changed. So we're going to just seal this up and set it up, and I'll show you what I do to help them be a bit more reliable. So I've got the TV plugged in, and I factory reset it as well. I'm just testing it here. So one thing I like to do for LED TVs after I fix the backlight or the backlight circuitry on them is I like to go into the menu, go into the picture option on LGs. Now LGs have a funny way of this. So if you set the backlight to just say 0 on the free view, you keep it as that on the free view, and then if you changed it to HDMI, I'm pretty sure it goes right back up. And it's the same for any source that you change on LGs. So what I find it's best to do is you just set this, let's just set that at 50%. It doesn't really matter, because it's on auto on Freeview, so you know, it changes depending on what screen the TV is displaying. I like to go picture, and I like to go energy saving at the top. I set that to medium. I mean, if you set it to maximum, it's I think when it's on off, it's I think 100% variating for the backlight, so it goes to 100%. Then if it goes to a full black screen, the backlight goes dimmer to increase the black level, or if it's on like a green screen or just a colour on the screen, it dims it to make the colour not as washed out. But if it's like an image like this where there's all sorts going on and there's some white as well, it puts it up to 100. So what I like to do is set it to medium. I think on medium it's at 50% the backlight. You know, on minimum it's pretty bright, but on medium it's about the same brightness as the VESS 315 on medium brightness as well. So, and this is perfectly watchable like this. So, but when you do set it on medium, it keeps the backlight. It says 75%, but it's actually dimmer than that. I think it's about 50%, but it keeps it like that for all sources. So you notice medium. So yeah, it's just a couple of things I do on LED TVs. And this has been the repair of this LG 32LN 5400, and hope it helps somebody. So thanks for watching.